Good evening, all. I welcome to today's webinar conducted by the Management Committee for 2024-25 of IESLWA chapter. Today's title, From Mining and Mineral Processing to E-Waste, Circular Economic Solution for Resource Limited Future. Presented by Dr. Saman Ilangkon. Thank you, Dr. Saman Ilangkon, for accepting our invitation and volunteering for this presentation. I wish to give you a brief outline of how we run today's webinar. The webinar will start shortly after my introduction, and the presentation will run for about, say, 40 to 45 minutes. We are short 5 minutes now already, so we'll say about 40 minutes. We kindly request you to mute your microphones during the presentation to avoid any disturbances. So at the end, there will be a Q&A session, and you can also type your questions in the chat box during the presentation, but we will take up all at the Q&A session at the end. So if anyone of you need a CPD certificate, kindly send us an email addressing to secretary@ieslwa.org. Okay, so now I would like to give a brief introduction of our today's presenter. Dr. Saman Ilangkon is a senior lecturer in the Department of Chemical Engineering at School of Engineering, Monash University, Malaysia campus. He is leading the Waste and Critical Metals Sustainability Group, research group. He graduated from University of Moratuwa, Sri Lanka with BSc Engineering Honours degree in mining and minerals processing. In 2012, he obtained his PhD from the Royal Schools of Mines at Imperial College, London. He's a chartered engineer of Engineering Council of UK. In addition, the Institute of Materials, Minerals and Mining, IOMO3, London, recognized his research work, including critical metals, sustainability, waste management, and climate action. So thus he was awarded a fellowship, OMO3 fellowship. Dr. Ilangkon is keen about teaching practical engineering aspects to young engineering students by employing novel pedagogical approaches. His commitment to teaching and professionalism in learning and teaching in higher education was recognized by Advanced HE UK, and he was awarded a fellowship over there. In addition, he is currently a visiting professor at University of Science Technology, Beijing. Today, Dr. Saman is going to present us from mining and mineral processing to e-waste, circular economic solution for resource limited future. Okay, Dr. Saman, I will hand over the floor to you now for your valuable presentation. Thank you very much.
Thank you, Mr. Ravindra. Thank you for the introduction and then for the invitation to deliver this speech on behalf of ISL Western Australia. I've been recovering from cold. My voice is a bit different. Sorry for that. Let me share the slides and then I can start the talk. I hope now everyone can see the slides. Can you?
Yeah, I think so. Yeah, it's good. Yeah.
Okay. So if during the talk, if my voice is not heard, please let me know because it could be due to the internet connection as well. I presume now the connection is good and you all can hear me clearly. Okay, so then I'll start, and today I would like to talk about how mining and minerals or the resources industry is related to our current lifestyle which is of course related to a topic known as e-waste. I'm not going to talk about e-waste at this point because I'm planning to get your insight as well. In addition, since e-waste is a global waste management issue, we are targeting circular economic solutions because our resources are limited. So considering these keywords, I'm going to deliver my talk today, and I hope you're going to learn something on this topic. So firstly, I would like to start from the SDGs, or the Sustainable Development Goal, and specifically, I would like to pick the goal number 12, which is the responsible production and consumption. Especially considering the population growth in Asia, and it will be more than 5 billion in 2015. So we have to produce significant amount of metals and the metal products using limited amount of resources. In other words, we have to do more and better with low amount of resources. So once I use that wording low resources, I would like to highlight by giving few specific examples. So nowadays we are talking about carbon neutrality, which is quite a hot topic. We are talking about electric vehicles, wind turbines, targeting carbon neutrality in 2050. In addition, the other key term is the critical metals. There are two critical metal lists, one from the USGS in the States, the other one in the European Union list. So there are about 34 to 50 metals and minerals in those critical metals for our carbon neutrality goals by different governments in the world. In addition, different manufacturers, including the car manufacturers, these critical metals are really paramount. However, achieving these critical metals, we only have the low grade resources, which are our current natural resources anywhere in the world. So I'm showing this picture that I've taken in an exhibition mine in Colorado, which is an underground mine about 100 feet down. So in Colorado, once we have the Colorado gold belt about 150 to 100 years ago, this entire space or that entire vein was filled with high grade gold containing rocks. So then everything have been extracted over the years, and now if we drive from this place to a few kilometers away, so then we have this another gold mine. It is known as the Cripple Creek and Victor Gold Mine, which is a heap leaching facility that operates with about 1 gram per ton gold resources. So in other words, to extract 1 gram of gold, we need to mine 1 ton of rocks. And since the ore is quite low grade, and that is why the heap leaching is utilized, because in order to practice the other mineral processing method, that grade, this grade is not quite enough. Then this is another mine. This is in India. It is known as the Hathi Gold Mine through the gold belt in India. So British started this mine in 1950s with about 50 gram per ton gold, and now their grade is about 3 gram per ton. So out of this 3 gram per ton, they get 90% out of it. So they are producing a waste dump containing about 0.3 gram per ton. Again, the company management always complain about the ore quality. So they are typically saying we are not getting enough profit, and our ore grades are now quite poor ore grades. So if you look on copper, this is the copper story in the last 100, 120 years. I extracted this from my colleague Gavin Matt's paper. So initially we had about 3%, then about 7% thanks to the geologists in Australia sometime in 1930s. And currently we have about 1% of copper. And based on my discussions with Rio Tinto now, we have about 0.6 gram, 0.6% copper grade, which is okay at the moment, considering the capital and operating expenses. However, you can see the evolution of the copper grades in the last 120, 130 years ago. That is the copper resources we have, but this is the copper requirement or the copper consumption. Again, in the last 100 or more than 100 years. So it is more or less exponential growth because copper is one of the critical metals for our current and sophisticated lifestyle. So in order to produce this amount or more than that amount of copper, we have to do our mining and mineral processing operation really, really effectively. Otherwise, we are not getting the enough amount of resources. So then I'm showing this picture because South China, especially Jiangxi, that is quite famous for the rare earth element and especially heavy rare earth elements. I assume you have some idea about the rare earth elements and the heavy rare earth elements starting from this gadolinium until lutetium plus yttrium in our periodic table. So heavy rare earth element extraction is quite easy. We only need ammonium sulfate solution. That is why the people or the informal miners in this area extract the rock from these mountains. And here you can see a well here. So they carry out a simple leaching operation to get a crude rare earth concentrate, and they sell this crude rare earth concentrate to the other suppliers in the region. But the damage is quite obvious, and that is how we produce rare earth to make our electric cars and make our wind turbine, especially in the informal sector. So then the related stories, even there are conflicts in some part of the world. So these conflicts are turned into mining businesses. So this is Myanmar. This is more northern state of the Myanmar known as the Kachin state, which is closer to the Yunnan border in South China. So even in this Kachin state, there are a lot of illegal and informal heavy rare earth mining happening. They can only produce a concentrate. The concentrate produced in the Kachin state, those are transported to the processing factories in South China to get the rare earth elements for the end application. So in some cases, our mining business is a human tragedy connected to the conflicts. I have one more example. So thanks to YouTube, I extracted this video. So this video shows the coltan mining in Eastern Congo. In short term, coltan, col means the columbite, which is the niobium mineral, because the columbium is the old American name for the niobium. Then tan means the tantalite, which is the tantalum mineral. So especially using tantalum, we get the metal mainly for the small capacitors that we use in our mobile phones, computers, and all the electronic gadgets. I think without tantalum capacitors, it is pretty harder to make modern electronic items. Again, this one, human tragedy connected to the child labor and the environmental pollution in order to get these critical metals. I hope my connection is okay because I cannot see the Zoom screen. Okay, seems good. Then,
yeah,
while doing all this,
okay. Yeah.
Sorry?
It's okay, yeah.
Yeah. While extracting all these important metals from low-grade resources, we are making different electronic products. If I give you some numbers in Australia, that electrical and electronic goods industry or its retail in 2023, it's equivalent to 25.4 billion Australian dollars. If you look at the definition, according to the European Union definition. So any household or industrial equipment that operates with less than 1000 volts AC current and less than 1500 volt direct current, these are known as the electrical and electronic equipment. So based on this definition, you can identify some of these electronic equipment and their categories. I'll go through this equipment in a bit, but I would like to give you some numbers. Currently, we have about 2 billion mobile phones, if we consider as numbers, and 90% of the global population, they own mobile phones. So that more or less tells us about the current lifestyle that we have. In addition, 80% of the carbon and environmental footprint during the design and the manufacturing stages, which means the mining industry significantly contributes to the carbon emission, especially during the production stage of the metals and the materials. So these are the categories. These are the 6 categories. Note that still we are talking about the electrical and electronic equipment. The first category is the temperature exchange equipment, something like air conditioners and refrigerators. Secondly, we have the screen and the monitors, tablets and the computer monitors. Third category is lamps. The fourth one is the large equipment, the washing machines, and then the PV panels. Then small equipment, the calculators, radio sets, video cameras, everything is categorized under small equipment. And finally, we have our mobile phones. These are categorized under small IT and telecommunication equipment. Okay, then the next question is, we talk about mining, we talk about the production of the electrical and electronic equipment and their categories. So then what is the relationship between the EEE and the term e-waste? I'll show you this slide as well to give you some perspective about the number of metals that we need to drive our current lifestyle or the current gadgets. If you take a mobile phone, so this is only example only, we need about 40 metals. So these 40 metals includes precious metal such as gold and silver, base metal, copper and nickel, and some critical metals because I talk about tantalum using tantalite. And then the final category is neodymium. Once your phone vibrates, that small vibrating motor in your mobile phone that is made using the rare earth elements. Okay, I don't like to talk continuously. I would like to, before my US definition, I would like to give this Slido question. Please scan this QR code, that QR code. If not, you can go to slido.com and add this code. Then my question to you is, when you hear the word e-waste, what are the first 2 and 3 words that come to your mind? So please take 30 seconds to respond to this question. So if you are new to Slido, there are 2 options. The first one is scan the QR code. Then the second one is please go to slido.com and add this code 1978568. I hope you can access the question. If any issues, let me know. Yeah, I'm getting responses. I'll wait 30 seconds, then I'll show your responses. If any difficulties of accessing Slido, please let me know. Okay, others. I can see 8 participants. I'll wait another 10 seconds. Okay, someone is typing, so okay, last 5 seconds. Okay, I'll stop here. So this is a word cloud generated by your responses. I can clearly see the recycling. Yeah, that is very true. Then you have mentioned electronic waste, toxic matter, then other gadgets like computer, mobile phones, and then someone added valuable elements. Yeah, again, I can see the toxicity wording, and I can see the battery as well. Okay, the valuable elements, circular economy. Yes, I'll talk about this term battery bit later. And printed circuit boards, that is correct. Yes, your word cloud really represents e-waste in general. And now I have the platform to continue my the next part of the talk. This is a you mentioned some definition to the electronic waste. Yes, e-waste is known as electronic waste. And once our electrical and electronic equipment at the end of their lifespan or after a particular replacement interval are known as waste electrical electronic equipment, or we use the term WEEE or e-waste or electronic waste. I think someone has mentioned batteries, but batteries are not categorized as electronic waste because we follow the European Union definition, and there are separate legislation for the batteries, and that is why we are not categorized in batteries. In addition, we are not adding electric vehicles, so they are component as e-waste. Again, there's a separate legislation for that one. We consider photovoltaic cells under large equipment. And if I give you some numbers considering the current e-waste generation, so it is equivalent to about 31 of metals in 2022, 2 billion. This is really. Let me talk about waste generation composition. About 62 million tons or 62 billion kilograms, which is equivalent 0.8 kilogram per capita per year. Actually, this number in 2019 was about in 2030. If you consider Asia, we generate about 48% of e-waste or about 30 million tons. Problem is, out of that 30 million tons, we only properly collect and recycle about 3.6 million tons or about 12%. What happens to the remaining 88%? That is a concern, especially in Asia. The most of the fraction is handled by the informal sector, and the remaining fraction ends up in landfills. That is a sad truth concerning these devices. And here I picked 3 different countries. Sri Lanka, we generate about 0.175 million tons because in Sri Lanka, our electrical and electronic sector mainly depends on the imports to the country. And if I pick Australia, Australians generates 0.6 million tons, and the per capita generation is really, really high because e-waste generation is a function of GDP as well. So that is why compared to Sri Lanka, like 8 kilograms per person per year, the number in Australia is quite high. India, the world's most populous country in terms of e-waste generation, they take the 3rd place, producing a bit higher than 4 million tons per year. Why I pick India? Because in India, e-waste generation is 90% or about that range, dominated by the informal sector. So then, if we take these countries, like in Australia, there are proper legislation frameworks to collect electronic waste. But in India, yes, we have the regulations, but I told you that it is pretty difficult to enforce the regulations. So then in Sri Lanka, there are no formal regulations to effectively capture or collect electronic waste. That is the trouble that we have. Even we have the Basel Convention, which limits the e-waste transport from one country to another country for the disposal. So the Basel Convention, it doesn't properly alleviate the e-waste transport from one country to another country. That is another trouble or another challenge that we have concerning the e-waste management. If I talk about the e-waste composition, I talk about the metals, which was about 31 million tons. That mainly includes the precious metals, base metal, and about the toxicity elements. So indeed, there are some heavy metals. Then the other issue is e-waste also consider significant plastic fraction, and that plastic fraction is again toxic because if you take your mobile phone, you can sometimes see that your mobile phone after a long call, it gets warms up or the temperature increases. So then while manufacturing electronic devices, in order to protect your electronic devices by fire hazards or the temperature increase, we add brominated flame retardants. So because of the brominated flame retardants, the plastic fraction is hazardous, which is recognized even in the Stockholm Convention, because e-waste or some e-waste fractions contain elements known as persistent organic pollutants. Okay, my next question. So what happens if our e-waste ends up in landfills. So it seems like a pretty easy solution, but what are the consequences? So the first consequence is we are losing that 31 million tons of metals. And some of you mentioned about the PCBs. PCBs contain more copper, silver, gold, platinum compared to our natural rocks that I was talking about in my earlier parts of the slides. So in other words, we have more concentrated elements in electronic waste compared to our natural rocks. So therefore, we should not dispose of these fractions in landfills. We have to plan urban mining operations in order to maximize the value recovery from electronic waste. Then the next aspect is if we dispose the electronic waste in landfills, which happens in some part of the world, unfortunately, so slowly these heavy metals leach into groundwater and soil and it destroy our ecosystems. It is pretty difficult to identify the effects because nowadays our landfills are filled with municipal solid waste items as well, but surely the slow leaching could happen and then it will give us quite long-term effects. Now, now in this part, I'll be tempted to discuss the recycling and the reuse aspect of the electronic waste. According to the LCA studies, before we think about recycling, reuse is a more effective solution. However, if we consider our mobile phones and laptops, we typically tend to buy new devices rather than reuse. I understand the practical concerns. Sometimes reuse is not cheaper. In addition, considering our lifestyle, our mobile phones and computers are currently filled with videos, photos, different personal data, and financial data. So then we consider about the data security. We don't like to give our mobile phone to a repairman to repair it. We don't trust them. So data security is another concern that we don't like to do e-waste reuse or refurbishment. This is another interesting aspect. If we take our mobile phones, we don't have, let's say, considering the mobile phone giants like Apple and Samsung and the other players, they don't give the chance for us to reuse or repair our electronic gadgets. This is I'm not sure whether you heard this phone model. It is known as Fairphone in the Netherlands. This phone is designed for the upgrades. The DFE means the design for environment. This is known as the modular phone. Modular phone means different phone camera mode for see the prices for different components. Then no need to go to a shop while sitting at home and using a small screwdriver, we can do the repair. So if we have similar options from the other players, we can extend the duration of our mobile phones or the lifespan, which reduces the e-waste generation. But unfortunately, we don't have such extensive options. Okay, I hope my internet is clear enough. If you have time, I mean, you can access their website and get more information. It's quite a nice idea, but I didn't get the chance to use one of these phones, so then I don't know the exact user experience. Okay, So then let me discuss the recycling part before any e-waste recycling operation. Now, if the reuse or the refurbishment is not a viable solution, then the only option should be the engineering recycling of the electronic waste. However, before we recycle electronic waste, the collection should be maximized. I would like to give my second question to you. Option against the same Slido code. So please tell me, what do you do with your broken or no longer usable electrical and electronic products? I think there are about 9 options. So my options are put into a garbage bin, put into an e-waste bin, exchange for new items, strip for spare parts, give sell to an informal collector, take to a local recycling center, sell as second-hand items. Then the next one is give to a friend or a family member and put in storage. I think you can add more than one option. So this will give me some insight about your electronic waste disposal habits. Sorry. I'll wait another 20 seconds until you add your responses. Okay, others, please participate and then add your responses. Okay, last 10 seconds. This will give me a water break. Thank you. Okay, 5 more seconds. I can see 9 responses and the options. Fortunately or unfortunately, yeah, we have all the options for the e-waste disposal. Yeah, if you're putting an e-waste bin and you know how to access those e-waste bin, I'm happy. But put into a garbage bin, okay, so that would most probably end up in a landfill. Then due to an informal collector, so then these items will be most probably handled by the informal recyclers who don't worry about the damage to the ecosystem. Okay, give to a family member. Yeah, that extend the lifespan and then the reduce the e-waste generation. Put in storage. Yeah, I can understand that one as well, which connects to the especially that value perception in our mind and then the data security concerns. Okay, so you can see I added, or I have given 9 different ways of disposing of electronic waste, and uh, small sample size in this Zoom meeting. They are using all these options, so that is the reality on the ground as well. Okay, thank you very much for these responses. Then yes, you can see here. Previously, I talked about lamps, and these fluorescent lamps, they contain, or inside fluorescent lamp, and as kids we used to break this fluorescent lamp because that I think that time we didn't know about the electronic waste or the issues associated to the electronic waste. Inside fluorescent lamp, there is a phosphor powder that contain the rare earth elements. However, extracting of the rare earth elements from this fluorescent lamp, that one is a really, really difficult job. And that is why some people dispose these lamps with the food waste. I mean, I have taken these photos in Malaysia, and these items surely end up in landfills, polluting our ecosystems. Then in some countries, I talked about India before, in some countries, informal sector dominates the e-waste collection, especially in India, they use a modified bicycle, and these informal collectors, they travel 30-40 kilometers in a day to find different items, including other solid waste items. They, out of their solid waste items, they collect about 10% of e-waste. So similar are operating in Malaysia to collect some electronic waste and these solid waste items. I don't like informal recycling, but these informal collectors, they have a very good eye when they chase for electronic waste items. They know what to buy. So therefore, these people, in terms of the collection, really, really doing a valuable job to collect e-waste. Otherwise, most of the e-waste would end up in our landfills. In Sri Lanka, we also have a very high or dominated informal sector. I think in Sri Lanka, this is commonly known as a scrap iron collection. Once they collect scrap iron and the other items, other solid waste items, they collect electronic waste as well. This is a compressor extracted from refrigerator, and the informal collectors, they really like these items because they can easily extract about 0.5 or 500 gram to about 800 gram copper fraction, only cutting that metal part. You can issue is, you can see here tubing. During the dismantling process of this refrigerator, all the CFCs emit to the atmosphere. Then you all know that it destroys our ozone layer. So then you can understand the benefits and the issues associated with the informal collection and the recycling. Yes, it gives us a very easy copper fraction while all the CFC escaping to the atmosphere. So that is why I propose to the United Nations, rather than destroying the informal sector, we need to formalize the informal sector. In other words, if we provide the guidance to the informal sector and ask them to only collect the items, and end of the day, provide these collected items to a formal recycling facility, that should be the right way forward, rather than simply kicking out the informal people from their current financial activities, or from, because they are only getting their current income mainly collecting these electronic waste items. Other than that, in our research, we propose IoT-based or the mobile app-based electronic waste collection systems. I'm not going to discuss the details of this. If you are interested, we can have a discussion. And luckily, I'm not sure. I presume you have some options in Australia as well. And luckily, in Malaysia, now we have the reverse vending machines that accept electronic waste. So this machine shows only the plastic waste disposal, but the same company offers electronic waste collection system using a mobile app-based reverse vending machine that utilizes Internet of Things. So these are positive aspects because we need to maximize electronic waste collection. Okay, so I'm now moving towards the last part, and I would like to give you some insight about recycling because I talk about the collection, informal and more formal collection mechanisms. After the collection mechanisms, then the recycling happens to extract the value fraction. Again, informal recyclers are there because I told you informal collectors, they supply the materials to the informal recyclers in a small alleys in KL city center. So you can see they use the small tools, the cutters. In addition, they get the power supply from a nearby restaurants. They break even whatever the collected ones, easy to recycle items, mainly targeting copper and the collected copper. It is pretty difficult to have a chat with them, but I managed to talk with these people to learn about, I mean, what they do and how they sell their items. Uh, so they, if the current market price of copper is about 35 Malaysian units, so they sell their items to 20 ringgit. So 20 ringgit is about like I think the $6, $6 Australian. So that is how they process the items. I think some of you mentioned the PCBs before. They don't have the technique to process the PCBs. They only have the technique to process the motors and the transformers because these are the easier items to process. Similarly, these are the photos we captured in New Delhi after the collections. So these guys, without using any PPE, they carry out the dismantling activities to recover some of the valuable items because this dismantling process, similar to the crushing and milling in our mining industry, then the dismantling is the activity that increase the value of the items. Do they carry out open burning to get the metal fraction? Unfortunately, the answer for that one is yes. This is a video I recorded in Sri Lanka, very quite closer to my sister's house. So what happening is, so one of the informal collectors, I mean, in this video, is burning the collected fraction. For example, to get the copper from the copper wires, or to get the aluminum fraction from a refrigerator door, they are burning all these items, and this burning is quite quick. Within half an hour, everything will be gone. However, they are doing a massive damage. If you are sitting in Australia and saying that, okay, this is happening in Sri Lanka, I mean, there are no effects. That is not true. And scientifically, it is proven that uh, from a higher temperature to a lower temperature, so the emitted toxic gases or the compounds, mobilization happen. So therefore, this is a global issue, the open burning of e-waste that destroy our entire ecosystem. Then once I discuss more formal operations compared to our mining industry or the minerals processing, crushing, milling operations happen in more formal industries with a proper engineering control. And because of the presence of the because of the presence of the non-metal fraction or the plastic fraction in e-waste. So here the Wilfy table is used and the gravity separation is the mechanism happens here. Once the metal fraction is separated from the non-metal fraction after crushing, milling, and then the wet gravity separation, then metal fraction can be used to further extract different metals. But the issue is in developing countries, mainly the hydrometallurgy is used to extract few metals, about 3-4 metals, which is quite different to what is happening in developed countries. There's the one operation in Umicore, which is in Belgium. In Umicore operation, pyrometallurgy and hydrometallurgy combined operations are used, and they extract about or more than 20 different metals. Firstly, the smelting in the hydro or pyrometallurgy or in a smelter, it gives a bullion, and the metal bullions is separated into individual metals by different hydrometallurgical operations. So then the next question is, can't we use these kind of operations in developing countries? The answer for that question is no, because to construct this sophisticated operation in developing countries, the capital costs are really high, order of 100 million US dollars. In addition, once the operation or the once the process is built, we must run the plant continuously. For that, we need a significant amount of e-waste supply. And that is why some businessmen, even in Sri Lanka, they separated the PCBs from the collected electronic waste, and they sell these electronic waste to Umicore in Belgium. Okay, so last few slides. I think a couple of weeks ago, I was in Thailand. So this Dowa group and the Dowa smelter in Japan. And you can see there are 6 ladies in this room with different tools. So in this subsidiary in Bangkok, so these ladies, they have the skill and the tools to separate and identify high quality and the low quality electronic waste items. I told you the reason. So these separated fractions are not processed in Thailand. They are sending these separated fractions to Japan because they have the smelter and they have the right techniques to maximize the value recovery from e-waste. So this is how the more engineered operations happen nowadays. Because of the cheap labor, separation or the dismantling happening in a more controlled environment, then the value recovery or get the maximum value, we must use the sophisticated techniques. So we are also looking at in our research how to develop novel flow sheets suitable for different countries, especially in developing countries. So once we consider the PCB structure, that is a sandwich and a very hard structure, we are trying to break this structure chemically rather than using crushing and milling. And our expectation is that the reduction of the capital and the operating cost. So this is my last slide, since my time is also limited. Then you can see more or less a futuristic image. Then I would like to give you some take-home message. And then my question here is, can we transform e-waste recycling in future mines? So here I'm trying to give you a concept where co-processing, actually we made this idea some time ago. So then I'm looking at the e-waste processing with natural resources at mine sites or e-waste recycling with mining tailings at mine sites, because certain aspects of e-waste processing happens at mine sites as well, because I mentioned the crushing, milling, and then gravity separation mechanism. So this is our conceptual idea, because otherwise, considering the high e-waste generation, it is pretty difficult to handle this global issue. And even some mining companies are moving towards that direction. But in Australia, still we have a lot of natural resources, and hopefully after another 20-30 years, this co-processing mechanism will be utilized. One of the example is that now Glencore Australia, at their Mount Isa operation, they are considering e-waste processing as well, because they have the right technology to process electronic waste. Okay, so then this could be a viable option for the future to handle our electronic waste. And yeah, that's the end. I hope we have some time for the question, and thank you very much for the participation. If you have any questions, I'm happy to answer.
Yeah, thank you, Dr. Saman, for giving us an insightful presentation today. Now the Q&A session is open up. So if anyone has any questions, it's your time.
Hello, Dr. Saman. I'm Dr. Nimila from Sri Lanka. Hope you can hear me clearly.
Yeah, hello, Nimila. Yeah, I can hear you properly.
Okay, thank you for the timely, valuable presentation. I have one question from you, sir. Here we mainly discussed about the metal extraction from e-waste generated in the global context. So my question is that do we have any industrial applications for the plastic fraction that generates through the e-waste?
Okay. Yeah, Nimila, thank you for that valuable question. I didn't get the time to discuss everything. So then my short answer is we need to be very careful. Why? Because the e-waste plastic fraction is hazardous, and especially in the European Union, it is not allowed to use that plastic fraction. I told you that mainly because of the brominated flame retardants, that fraction is hazardous. I can give you an example. If you use that plastic fraction and make a toy for kids, or you use the plastic fraction and make like a flower pot to grow tomatoes. So then there's a possibility of the mobilization of the toxic substance to the kid or to our food items. That is the main issue with the plastic fraction. But if you clearly identify the toxicity of those plastic fractions, then use that plastic fractions for some other applications, for example, in PV cells or other engineering applications, something like, let's say, making cars, we use the e-waste plastic fraction. So those kind of applications are rather feasible. However, if there is a direct human contact is involved, so for such things, it is not recommended. But considering the research, I mean, this subject area, it hasn't been studied quite a lot. And the other sad aspect is that especially the people who dismantle this e-waste plastic fraction, they give the plastic fraction to the people who collect other plastic items, something like plastic chairs. Then the person who purchase all this plastic, they don't know the origin of the plastic, where it comes from, like a household, or whether it is come from electronic waste item. And now, considering the overall plastic fractions, we are talking about, let's say, the good plastic and the contaminated plastic. That is a really challenging issue, but we need the proper solutions, especially in the developing countries or the countries who don't have the proper legislative frameworks. I hope I answered your question.
Okay, thank you, Dr. Saman.
Is there any
Hello,
other
Saman. I'm Nimal Jayaratna. Can you hear me?
Yes, I can hear you.
Yeah, you mentioned about metal extraction or separation of metals and plastics. What about non-metals in this e-waste? You know, that Belgian plant, what are they extracting out of the e-waste? Is there any
Okay.
non-metals?
Yeah, okay. Again, another valuable question. The non-metal fraction of electronic waste are mainly the plastic, glass fibers, and the other resins. Then, if we talk about the Umico operation, since the initial operation is a pyrometallurgical operation, then this non-metal fraction, it will be burned inside the smelter, which reduces the energy cost to run that smelter. So therefore, in Belgium or the integrated pyrometallurgical hydrometallurgical operations, non-metal fraction is not extracted. Non-metal fraction contributes to the metal recovery by reducing the energy cost because they don't need to add too much coke for the combustion. So then they only get a metal bullion and the slag fraction. Then the slag fraction is removed, and the slag fraction can be used as like a construction product. Then the metal bullion, since it is a product of number of metals, we need a hydrometallurgical operation and followed by the electrowinning to get the individual metal or the metal oxides. So the issue of the non-metal fraction mainly in hydrometallurgical operations in developing countries or in more small scale operations because after separating, let's say using the magnetic separation or the gravity separation, so these profit oriented small scale companies, they mainly focus on the metal fraction and getting few metals out of it, especially copper and zinc, silver, so the and gold, and they don't focus on the separated non-metal fraction. So what normally happens is they find a contractor to give this non-metal fraction, which is of course hazardous, and eventually ends up in other plastic supply chains or ends up in a landfill.
So can't these gases escaping from the what do you call that, the smelter,
Yeah, yeah.
treated
That
and the neutralized and used for something else?
okay, that's correct. In smelters, because these are sophisticated smelters, they have the gas capturing system. Whatever the gas that escape to the atmosphere, those are captured, and in some cases, especially if there are enough sulfur dioxide, that can be used to make chemical products, especially sulfuric. Yeah, these things happen in the few smelters in the world. One is a Umico, the other one is a Dowa. Then we have the Noranda smelter run by the Glencore in Canada. Then there's another one in Sweden. There are, I think, 6, 7 smelters around the world, which are properly engineered smelters and the mineral processing operations. I think the hazards of these sophisticated ones are quite limited. I cannot say zero, but I mean, they run their operations quite smoothly. Then the other important aspect is rather than focusing on 2, 3 metals, they focus on more than 20 metals or number of metals.
Or elements.
I would say. Yes, correct. Yeah.
Thank you.
Welcome. Yeah.
Yeah, any other questions from audience?
I can see
Ravindra,
one question.
yeah, one question from Gimhani, the chat box. Yeah, Ravindra, go ahead.
Yeah.
Okay, so Gimhani's question is, are there any methods to handle the toxic byproducts generated during the recovery of metals from e-waste? Okay, so Gimhani, my answer for this one is we need to understand the scale of the business. If we talk about hydrometallurgical operations in developing countries, So industrial players, they really don't bother. And there are some lab scale studies idea recovering the hazard byproducts, but we need to closely work with the industries to separate and properly handle these byproducts. The reason is I mentioned before, the industry is mainly profit oriented, so I don't blame for that aspects, but I mean they are not really focusing on the toxic elements in electronic waste. Then in order to address that problem, we need very strong legislative frameworks. If we have those, I mean, we can handle it. Then in developed countries, in integrated operations, they really do number of things to capture the toxic byproducts. So then for your question, the answer is both yes and no. Unfortunately, in the informal recycling sector, because I told that I like the informal collection because it is really, really efficient. However, informal recycling, they really don't care about the plastic fraction and then the associated byproducts. So I think considering the different scales of the business, I hope I answered your question. If you have any other comments or questions, let me know.
Okay. Is there any other questions by audience? And also there is nothing on chat box anymore. All right, so we are grateful, greatly thankful, Dr. Saman Ilangkon, for accepting our request to do the presentation for the ISLWA chapter webinar series today. I'm sure that we all were able to gain new knowledge from this presentation, and we had a lot of questions raised and answered. Yeah, so that's great. So in behalf of ISLWA chapter and all participants today, I wish to thank you, Dr. Saman Ilangkon, for sharing your expertise at this webinar. As we mentioned before, if any of you needed CPD certificates, don't forget to send us an email addressing to secretary@islwa.org. Okay, so thank you all for joining us today, and looking forward to seeing you at our next webinar. And stay tuned with ISLWA emails, LinkedIn, and Facebook. Okay, thank you.